Okay, this is part 2 of 4.2, still reflecting. In this case, I want to reflect this line segment AB over the line y equals x. So the first thing I need to figure out is where the line y equals x is. So if you recall, this equation is actually in the form of y equals mx plus b. So it's a linear equation. The slope is 1 or 1 over 1. The y-intercept is 0. So you start at 0 on the y-axis, go up 1, right 1, and just continue that pattern. So the line y equals x would look like this. And that's the line of reflection. I'm going to label it as well. So I need to reflect point A and I need to reflect point B over that line. So first, reflecting point A. The distance of A to this line is right here, this segment. This segment right here, the slope is the opposite reciprocal of 1. It's negative 1. So notice it's 1, 2.5 diagonal segments. That's not necessarily 2.5 segments. It's going to be more than that because this right here is not just one segment, it's one diagonal segment. If I use a Pythagorean theorem or the distance formula, you would see this is a square root of 2. 1 squared plus 1 squared. And it's going to be the square root of 2. But the easiest way to think about it, in my opinion, is it's 2.5 diagonal segments above the line y equals x. So if I go 2.5 diagonal segments below the line y equals x, here's half, here's 1, here's 2. That would be the coordinates of A prime. So here's A prime, and the coordinates of A prime are 4, negative 1. And I could do something similar with point B. The distance of point B to this segment right here, or to the line y equals x, is 1.5 diagonal segments. And then it's below the line, so if I go 1.5 diagonal segments above the line, here's half, here's 1. This would be the coordinates of B prime, 0, 3. So I'm using prime notation. And then if I do that in a different color, right here. So originally I started with the blue segments. That was AB, or that's the pre-image. And then this pink segment is A prime, B prime. Those two segments should be congruent because just like with translations, a reflection is what's called a rigid motion. Okay, it preserves length right here.